So yesterday we talked about opposite coefficients. But if you remember, I did not use the word opposite coefficient. Anybody remember what I said you were talking about? But in systems and equations, how could I start to eliminate? What were we trying to find first? What was the first thing we tried to find? What's our first step in this equation right here?
Zero pairs.
Zero pairs, right? So I call this zero pairs. But really what it is opposite coefficient. Coefficient is always the number in front of a variable. We know that these are opposite coefficients because this one is positive and this one is negative. So today we will be solving systems by rewriting them to look like B. So what we have for A, we want it to rewrite it to look like B. So in which system do you see opposite coefficients? You see it in the front? Right here. You have opposite coefficients in here? I just said the coefficients are the numbers, right, in front of the variable. There's no opposite coefficients in there. Are there opposite coefficients in here? Yes, we already identified them. So those are zero pairs. So let's talk about what's 4 equals to 4. What if I took 4 and multiplied both sides by 2? What would I get? 8. Does 8 equal 8? What if I multiplied both sides of the equation by negative 2? I would get negative 8. So that being said, what could I do to make A look more like B? Negative 2y. What do you mean? X plus 2y equals 3. X plus 2y equals 3. Are those the same? Are they equivalent? Yeah. They are. What about 3x minus y equals 2? 6x minus 2y equals 4. Okay. Good, Michael. If I multiply both sides of this equation by 2 and distribute, then I would get the equivalent equation. Use elimination to solve the system of equations. Let's look for opposite signs. Who can tell me where you see opposite signs when comparing these two equations? Patrick, raise your hand. Thank you. The B's, right? This one has a positive and this one has a negative. But do they have the same coefficient? No, they do not have the same coefficient. What can we do to change that? Anybody have any ideas? Good. So if I multiply the top of this equation by 3, well, first we look at which equation has, or I'm sorry, which variable has a positive and a negative. We look for opposite signs. We notice that the B's have opposite signs. Then we look at how they relate. Well, 30 is 3 times larger than 10. So if we made 10 3 times larger, wouldn't they match? Mm-hmm. So we make 0 pairs then? Mm-hmm. So that's where I get the 3 then. Okay? So now when I multiply with 3, or distribute with 3 to everything inside of the parentheses and the 3 on the other side of the equation. Now I get 60A plus 30B equals 270. And for the second equation, I'm just going to copy it down. 10A minus 30B equals 80. Now we have opposite coefficients. So what do we do with opposite coefficients? Sarah? They cancel each other out with their 0 pairs. Now we're going to simplify our equation. 60A and 10A make 70A, and that equals 350. If 70A makes 350, then I know if I divide up 70A's, I'm going to get 50. Okay, so now that I know that the quantity of A is 5, what am I going to do with 5? Wait, think, substitute. I want to substitute A back in. Which equation am I going to substitute A back into? Why? Okay, good. It's easier. It doesn't really matter though. Whichever one that you want to. Whichever you're more comfortable with. Okay, so now I have 10 A minus 30 B equals 80, and I know that A is equal to 5. So 50 minus 30B equals 80. If I remove 50 from both sides, then I get negative 30B equals 30. Divide both sides by negative 30. Sure, don't forget that negative sign. No common error. Cancel. Cancel. What am I left with? So what's my solution?
5 and negative 1.
5, negative 1. What does that represent?
The intersection.
The intersection of the two lines or the system. Good job. Okay, so let's look at what's different about this one. Do I have opposite coefficients anywhere on this system of equations? I don't see any. I don't see any opposite coefficients. So what do we need to do?
The bond make everything else.
We can make opposite coefficients, right? But not only do I need to make opposite coefficients, but what else do I need to do?
Make everything else.
Do these match right here? 6 and 3. 2 and 7. Am I going to be able to make 0 pairs at all here? Alex, am I going to be able to make 0 pairs at all here? I am? How? How can I make 0 pairs? Because as it is now, if I apply a negative to either one of these equations, I'm still not going to have a 0 pair. So what should I do? Patrick? Uh-huh. Back to the 1. Perfect. I'm going to multiply the bottom equation by negative 2. So by doing that, I now have negative 6G plus 14H equals positive 38. Now I have opposite coefficients that can. Let me simplify my equation now. 14h and negative 2h. Are those different signs or same signs?
Different.
Different. So we want to find the difference between them. What's the difference between 14 and 2?
12.
12. H.
No.
Is it a positive 12 or is it a negative 12?
No. Positive.
Positive because the 14 has more positives. So 12h equals 48. And Mrs. Muller's not going to write 48. What am I going to write?
12 and 4.
12 times 4. Why do we do that, Elton?
Yeah.
I faster so that I can simplify it immediately. Because when I divide both sides by 12, I can say 12 divided by 12 is 1. 12 divided by 12 is 1. This simplifies to h equals 4. What's my final step? Substitute. Elton, which equation would you like to substitute back into? Okay. This one? And I'd rather that be red. Okay, so when I substitute that back in, I have 6 G, and I know, you don't know what G is. 6G minus 2 H's equals 10, and I know that my H is 4. Add 8 to both sides. 6G equals 8. Solution of the system of equation. Which one comes first? The 3 or the 4?
3.
3. Why does 3 come before 4? Because G comes before H. Again, what does this represent?
Wait, where the line comes
Alright, so determine what you would multiply by if you're going to solve this elimination. So how can we solve using elimination? Can you explain it? Oh, perfect. So right here, did you guys all talk about? On this equation, J is the second term. K is the first term. On the top, they've got J as being the first term. That's one thing we need to do. Good job, Elgin. We would use the commutative property and switch these two around. Okay, what else should we do? Multiply the bottom by negative 3. Good, we can do that. If we multiply the bottom by negative 3, that would give us opposite coefficients, right? What could we have done instead of that? And we did. That's correct. You could multiply the top by negative 2, and that would also give you opposite coefficients, right? Okay, so let's do this together. 9J and set this up. 9J plus K equals 13. And negative 6, these around, negative 9J minus 6K equals positive 4. Now we have opposite coefficients, so we'll cancel each other out. And when I simplify my equation, I get, what's 6K and negative 6K and positive K?
Negative
5. 25. Then when I divide both sides of my equation by -5, I get k equals -5. What am I going to do with that? Substitute it back in. Which one would you like to substitute it back into, Michael? The first one? Okay. Okay, so 9j plus k equals 13, and I know that my k is equal to -5. So 9, I can run that. 9j minus 5 equals 13. I add 5 to both sides. And I get 9j equals what? 18. Divide by 9, divide by 9. J equals 2. So my solution is, which one comes first, J or K? J. 2, -5 is my solution. Okay, so these I have opposite coefficients, but they don't make a zero pair. So this time I could multiply the bottom equation by 4 and the top equation by what class? Does it have to be a -3? No, it's by 3. And when I do that, I would get 9w plus 12d equals -75, and 8w minus 12d equals 0.24, and I would solve accordingly.